Hi everyone, my name is Ben and this right here is Ethan, and we're both students at South Dakota State University. Before you watch this video, please watch the soil sampling video that was posted prior to this one, as that will lead into this one today. So today's video is about soil texture analysis, so let's get right to it.
So, what is soil texture? Well, soil is actually made up of many different parts, not just the solid particles. These other parts include organic matter, air, water, and living organisms. While all of these are important, soil texture just looks at the different sizes of the solid particles. Now there are three main sizes of soil particles that are used to determine a soil's texture. The smallest of the three is called clay. Clay particles are extremely small and can only be seen under a microscope. The middle-sized particles are called silt. They're still very small, but they're larger than clay. Silt is also smaller than the third particle size, sand. We've all been to the beach or played in a sandbox and know how gritty sand feels. These are the largest particles used to determine a soil's texture. Anything larger than sand, or larger than 2 millimeters, should be removed prior to doing the texture analysis. To figure out our soil's texture, we're going to be using something called the texture triangle. The texture triangle takes the percentages of clay, silt, and sand to produce a soil texture for your soil. As you can see, there are 12 main textures of soil, some of them better than others. So what texture is the best? The best soils are the loams found towards the center of the triangle. Loams have a good distribution of the three particle sizes and are good at holding nutrients and water. I will show you how to use the texture triangle later in the video. Now there are drawbacks to having too much of one particle size. For example, too much clay will have trouble draining water and may result in waterlogged soil or ponding. When clay soils dry, some of them can get rigid and new plants will have trouble penetrating the surface. On the other hand, soils with too much sand will have problems holding water and nutrients and may have to be watered and fertilized more often. So today I'm going to be showing you how to use the jar test method for textural analysis. First, you'll need a clear jar. Old salsa or pasta jars will work the best, just make sure they are clear. Glass also works better because it is easiest to see through. You'll also need a timer, ruler, and permanent marker for taking measurements. Lastly, you will need some form of powdered dishwashing detergent. In this video, we used borax. After removing any of the organic matter or large particles, the first thing we want to do is air dry the soil. To do that, we spread it out in a nice thin layer on a tray or plate so that it dries evenly. You're going to want to air dry your soil in a warm and dry place. After your soil has air dried, usually after several days, transfer the soil to the jars. You can then add water but leave a space at the top of the jar. Next, you're going to want to add about 1 tablespoon of dry cleaning detergent to each jar. This helps separate the soil particles from each other and gets them into suspension. Rigorously shake the bottle for about a minute or until everything is in suspension. Have your timer ready because as soon as you stop shaking, you need to start the timer. After shaking, set the jars on a flat surface and start the timer. It is best to have a lighter colored background as this will help distinguish the layers. After 1 minute has passed, make a mark at the top of the settled soil. This line represents sand that has fallen out of suspension. If it is hard to see the settled soil line, you can try shining a light through the back of the jar. After the sand measurement, the next measurement will be taken after 2 hours. This time lapse shows how soil slowly falls out of suspension. After 48 hours have passed since you first shook the jar, you're going to mark your clay line. The clay line should be above the sand and silt line and shows that most of the soil particles are now out of suspension. So, to recap, after shaking the bottle, all of the soil particles were in suspension. Due to gravity, they slowly fell out of suspension with the heaviest particle, sand, falling first. Because the sand is the heaviest and fell out first, the first line represents the sand portion of this soil. The second line you make after 2 hours marks the silt line, where all of the silt has now fallen out of suspension. Lastly, the third line marks the clay line, where all clay has now fallen out of suspension. The clay line also represents the total height, which will be used for our later calculations. The next thing you need to do involves taking measurements of the total height and each layer. The total height will be from the bottom of the jar up to the clay line. Although we put the same amount of soil in each jar, their heights are very different due to air pores that were in the soil. After you have the total height, you need to measure the distances between the lines to figure out the depth of each layer. For this soil, the sand layer is from the bottom of the jar up to 0.9 inches. The silt layer then stretches from 0.9 to 1.7 inches. And lastly, the clay line stretches from 1.7 up to our top of 3 inches. With the heights of each particle layer now measured, it's time to do some quick calculations. First, we're going to try to figure out our percentage of sand. To do this, we're going to take the height of the sand layer, divide it by the total height, and times it by 100. For our example soil, our sand layer was 0.9 inches. We divided it by the total height of 3 inches, times it by 100 to get 30% sand. Next, we're going to look at the silt layer. We're going to take the top of the silt layer height and subtract the bottom of the silt layer height, so the sand height, divide it by the total height and times it by 100. The top of our silt layer was at 1.7 inches, and that stretched down to 0.9 inches. So we're going to subtract those two and divide it by the total height of 3 inches, times it by 100 to get 27% silt. Lastly, we're going to figure out our clay percentage. To do that, we're going to take our total height and subtract the bottom of the clay layer height, so the top of the silt layer. Divide that by the total height and times it by 100. So our total height was 3 inches. The top of our clay layer was 1.7 inches. So we're going to subtract that, divide that by our total, times that by 100, and get 43% clay. Now that we have those three percentages, they should all add up to be 100%. If they don't, you made a calculation error somewhere. So now we can finally come back to the texture triangle. Starting on the left side of the triangle, you can see the percent clay stretches from 0 to 100%. For this soil, our clay percentage was 43%, so we draw a horizontal line at 43%. Next, move to the right side of the triangle and we'll look at our silt percentage. Since our silt percentage is 27%, draw a line diagonally downwards at the 27% mark. Lastly, the bottom of the triangle looks at the percentage of sand going from 0 to 100 from right to left. Since our sand percentage is 30%, draw a diagonal line upwards. If done correctly, all three lines should intersect at one point in the triangle. For this soil, they intersected in the clay zone, so this soil's determined texture is clay. Here is another example. For this soil, we have a much higher sand percentage than in the first example. We still start with a clay percentage of 27% and draw a line across the triangle. Next, we draw a line downwards from 18% on the silt side of the triangle. Lastly, we draw a line up from the 55% sand. These lines intersect in the soil texture called sandy clay loam, which is the texture for this soil. So, now you should be able to determine the texture of your own soil at home. This could come in handy for determining fertilizer requirements, how much pesticide to use, and creating a watering schedule. Thank you so much for watching today's video, and have a great day.